Hello friends, I am Neeta Kulkarni. Today we are going to discuss about the LED characteristics. As we have discussed the laser characteristics in the previous point, so in this point we are going to discuss the LED characteristics in comparison with the laser characteristics. Before studying the LED characteristics, first thing we have to keep in mind that LED is acting as a non-chromatic source of light. So it is not emitting the intense beam of light, spread beam of light is emitted by LED. So total 5 characteristics of LED we are going to see in this session. The normal or general characteristics of LED also we can write at it as it is the non-chromatic source of light. It emits low optical power at the output. Coupling losses in the LED are more. These are the general characteristics of LED. But specific characteristics of LED, if we are going to study, there are total 5 characteristics we are going to consider. First one is optical output power. Second, output spectrum. Third, modulation bandwidth. Fourth, reliability. And fifth one it is modulation. So 5 characteristics we are going to see. So let us start with the first characteristics, that is optical output power. So what is the meaning of optical output power? So in this we are going to see the output characteristics of LED. So output characteristics of any device is nothing but its graph of the output parameter versus the input parameter. So in case of laser we have seen the optical output power versus the input electrical signal. That graph we have seen in case of laser. So that graph it is not linear. So we have seen in that the laser emission will not start until the input signal is greater than the threshold current. Once the input signal is greater than threshold current, the light emission starts. So that is the case with laser. So we are saying that laser is not linear device. Now in case of LED, it is linear as compared with the laser, because as soon as the electrical signal is given to the LED, emission of light we are getting from the LED. So first thing or first difference between laser output characteristics and LED output characteristics is that the laser output characteristics are not linear, whereas LED output characteristics are linear. So in the graph, the output characteristics are compared for 3 LEDs. So mostly all these characteristics are compared with respect to 3 LEDs: superluminescent LED, surface emitting LED and edge emitting LED. So in the graph if you see, there are 3 types of LED. SLED stands for surface emitting LED, ELED stands for edge emitting LED and SLED stands for superluminescent LED. Already we have seen these 3 basic types of LEDs. So along or in the 5 types of LED that we have seen, planar LED and dome LED are the basic one. So those are not giving the more intense output as compared with these 3 LEDs. So the characteristics are compared with respect to these 3 LEDs only. The planar LED and the dome LED are not included in this. So output characteristics, if you see, in case of LED, as the temperature increases, the internal quantum efficiency of the LED it is decreasing. So this graph it is about the output power versus the temperature. So from this graph it is clear that as there is increase in the temperature, the output power it is reducing gradually. So this is the frequently asked question in the MCQ. In case of LED, with temperature increase, what happens with the internal quantum efficiency of LED? So whenever there is temperature increase in case of LED, the internal quantum efficiency of LED decreases slowly. So if you compare SLED, ELED and SLD. So here we have to remember specifically both the LEDs are starting from the name S, superluminescent as well as the surface emitting. So when it is specifically SLED, it is indicating the surface emitting LED, and SLD stands for the superluminescent LED. So in these three LEDs, superluminescent LED, its quantum efficiency, it is decreasing more as compared with the other two types. So if you compare these three LEDs, surface emitting LED, it is less temperature dependent, then edge emitting LED is moderate temperature dependent, whereas superluminescent LED, it is more temperature dependent. So in that type of LED, the output decreases more rapidly as they increase in the temperature. And this graph it is by considering the 1.3 micrometer wavelength. So same it is explained here. The edge emitting LED device exhibits a greater temperature dependence than surface emitting LED, then that the output of SLD with its stimulated emission is strongly dependent on the junction temperature. So this is the first characteristic. So in this we have seen the LED, it is linear device. As soon as the electrical signal is incident on the LED, we are getting light output. So linearity of LED is more as compared with laser. And another thing, what is the effect of temperature on the output characteristics of LED? So as the temperature is increasing, the output power decreases exponentially. That is the another thing in this first characteristics. So in MCQ, if it is asked which one it is linear device, so the answer will be LED as compared with the laser. Then the second characteristics we are going to consider output spectrum. So first thing we will understand what is the concept of output spectrum. So in case of electrical signals, for any signal on y-axis we are taking voltage and on x-axis we are taking time, because there the frequency it is main parameter. But in case of optical signal we are not using the frequency, we are using the wavelength. So frequency, as we are taking time on x-axis in electrical signal, in case of optical communication we are taking wavelength, because wavelength is the basic parameter which is going to affect on the various characteristics. So always if you see any graph related to optical communication, those graphs are maximum with respect to wavelength. So output spectrum is nothing but it is graph of output optical power versus wavelength. So it is graph of how much amount of power it is emitted by the particular optical source with respect to its wavelength. So as we are considering electrical signal, it is graph of its voltage with respect to time or any other parameter like power with respect to time. Here output spectrum of the signal is nothing but its graph of its power emitted with respect to wavelength, or power emitted by considering the wavelength ranges. So first thing we have to keep in mind that if the output spectrum is broad, that means the light beam emitted it is narrow, or in another words we can define output spectrum is nothing but it is the range of wavelength. As we say the bandwidth is nothing but it is the difference between higher frequency and lowest frequency. Similarly, output spectrum is giving the range of highest wavelength and lowest wavelength. So that is the concept of output spectrum. So if the output spectrum is broad, that means there are multiple wavelength ranges, and if the wavelength ranges are more, that means we are not getting intense beam of light at the output. So here we have to keep in mind that as much as our output spectrum is narrow, that much intense beam of light we are getting at the output. So in this, first we have to understand what is the concept of output spectrum. So it is the graph of the normalized output power versus wavelength. Also the width of the graph, it is giving the range of highest wavelength and lowest wavelength. If the graph or if the output spectrum is broader, that means more wavelength components are present and line width of the optical source is more, means it is not intense beam, so that source it is not chromatic. And in case of chromatic source, there is unique wavelength component, so the output spectrum will be narrow. That is the first concept we have to understand related to output spectrum. And in this graph they have shown what is the effect of increase in the temperature on output spectrum. So output spectrums are shown at three temperatures: 0 degree Celsius, 30 degree Celsius and 60 degree Celsius. So from the graph it is clear that as the temperature increases, the output spectrum it is broaden. So at 0 degree Celsius, the output spectrum it is having the more power. Also another thing we have to keep in mind, that as the temperature is increased, as we have seen in first characteristics, as the temperature is increased, the quantum efficiency of LED it is decreasing. So obviously the output power will be reduced. So output power it is reduced when the temperature changes from 0 to 30 degrees Celsius, 30 degrees Celsius to 60 degrees Celsius. So along with this decrease in the power, the output spectrum it is broadened. So these two things we have to keep in mind for this second characteristics. Output spectrum, it is graph of the normalized output power versus the wavelength. Also it is indicating range of the wavelength. If the output spectrum is wide, means range of the wavelength is more and that beam of light it is not intense. If the output spectrum is narrow, the wavelength components are less and beam of the light it is intense one. And as the temperature is increased, the output spectrum gets broadened. That is the another point in case of the output spectrum. That is the second characteristics of LED. Now the third characteristics of LED, it is modulation bandwidth. So first thing we have to consider that modulation bandwidth means we are going to do modulation of light. So in case of light modulation, as we know that for modulation we require two signals, carrier signal and modulating signal. So when we say modulation of light, light is acting as a carrier signal and whatever is the another signal, that is analog or digital, that signal is acting as a modulating signal. So characteristics of light are changing with respect to characteristics of the modulating signal. So there are two types of modulations, basically analog modulation and digital modulation, depending on which signal we are taking as a modulating signal. So when we take analog signal as a modulating signal, that is called as analog modulation. When we take digital signal as a modulating signal, that is called as the digital modulation. So if we compare analog modulation and digital modulation it is giving better performance as compared with the analog modulation. Again, based on which parameter of light we are going to change, there are three types of modulation. For example, in case of analog modulation, based on which parameter of analog signal we are going to change, there are three types: frequency modulation, amplitude modulation and phase modulation. Similarly, based on which characteristics of light we are going to change, based on that there are three types of modulations: intensity modulation, frequency modulation and phase modulation. But most of the time the intensity modulation it is preferred, in which the intensity of light it is changed with respect to the modulating signal. So these are the types of modulation of light. First two types are based on which signal we are taking as a modulating signal. There are two types, analog modulation and digital modulation. And another, based on which parameter of light we are going to change, there are three types: intensity modulation, phase modulation and frequency modulation. But out of these three, the intensity modulation it is commonly used. Now we are going to see what is the concept of modulation bandwidth. So bandwidth, it is the range of highest frequency, or it is the difference between highest frequency and the lowest frequency. So optical bandwidth, it is significantly greater than the electrical bandwidth. So that is proved in this particular graph. So we are saying that the optical bandwidth is more as compared with the electrical bandwidth. So in the graph, it is the graph of current ratio versus the frequency. So 2 points are compared here, electrical 3 dB point and optical 3 dB point. So as we know that electrical 3 dB point we are getting when the ratio of I out by I in reaches to 0.707, and optical 3 dB point we are getting when the ratio of I out to I in it reaches to 0.5. Means from this graph, if you take its projection, you get the particular electrical 3 dB point and optical 3 dB point. So if you compare the regions related to electrical bandwidth and optical bandwidth, obviously the optical bandwidth provided it is more as compared with the electrical bandwidth. So the graph it is of the frequency response of an optical fiber system showing the electrical and optical bandwidth. So in modulation bandwidth, these 2 points we have to write. First we have to write what is the concept of modulation of light, what are the types of modulation of light, and after that we have to draw this graph, show the electrical 3 dB point and optical 3 dB point, and from that graph it is proved that the optical bandwidth it is more as compared with the electrical bandwidth. That is the third characteristics of LED. And in first chapter we have seen that the bandwidth range provided by optical communication it is 10 raised to 13 Hertz to 10 raised to 16 Hertz. This is also the frequently asked question in the exam, that what is the bandwidth range provided by the optical communication. So it is 10 raised to 13 Hertz to 10 raised to 16 Hertz. That is the point related to the bandwidth provided by optical communication system. Now the next point or next characteristics of LED, it is reliability. So reliability of any device is nothing but its ability to give the same performance with the same efficiency for a longer time. That is the concept of reliability. So for any device, its reliability it is important parameter for its performance. So here reliability of laser we have considered. So here for optical sources, reliability we are defining by considering their degradation. So which types of degradations are present in laser and which types of degradations are present in the LED. So reliability of any device we are going to consider by considering its degradation. So in case of laser, two types of degradations are present: catastrophic degradation and gradual degradation. So there are two types of degradations in any optical source. Particularly those are taking place in case of laser: catastrophic degradation and gradual degradation. The catastrophic degradation takes place because of physical damage of the material. Means whenever there is damage in the mirror, or if some any delicate part of the optical source it is broken, that type of degradation comes under the catastrophic degradation. So when the catastrophic degradation takes place, suddenly the working of the device it is stopped and we are not able to get any output light from that optical source. So in case of LED, this catastrophic degradation is not present. So catastrophic degradation is present in only in the laser and it is absent in the LED. Another type of degradation present in the optical source, it is gradual degradation. So gradual degradation that is not related with any physical damage of the material, but it is related to some defect formation in the working of the active region. So in basic working principle of optical source, we have seen the active region is nothing but it is the area from which we are getting the emission of light. So in active region, if there is some defect formation, that is giving the error in the output light. So the output emission will not be suddenly stopped, but definitely whatever amount of light we are getting at output, that it is reduced. So in case of LED, gradual degradation is present. So if you compare the degradation in laser and LED, laser is affected both by catastrophic degradation and gradual degradation, whereas LEDs are affected only by the gradual degradation. So reliability of LED, it is more as compared with reliability of the laser. This is also the, so whatever are the characteristics of laser as well as for LED, those are the performance parameters as well as those are the comparison factors for LED and laser. So two characteristics are better for LED as compared with the laser. First one, it is output characteristics. So laser is more temperature dependent and LED is less temperature dependent. So in case of laser, as the temperature increases, threshold current also increases and delay is increased in the working. But in case of LED, as it is less temperature dependent, its linearity it is more as compared with the laser. Again, second characteristics, in case of LED, the degradation is less, so reliability of LED it is also more as compared with the laser. That is the fourth parameter of the LED. Then fifth parameter, it is modulation. So as we discussed shortly in third characteristics along with modulation bandwidth, what is the concept of modulation of light? So as we discussed, for modulation we require two signals. So again, short note, it is separately asked based on this LED modulation or laser modulation. Let it be LED or laser, both are coming under the light modulation type. So in light modulation, light is acting as a carrier signal. So we are changing the characteristics of light with respect to the modulating signal. So light is acting as a carrier signal. So first two types of modulations are based on which modulating signal we are using, either analog signal or digital signal. If analog signal it is used for modulation, it is called as the analog modulation, and if digital signal it is used for modulation as a modulating signal, it is called as the digital modulation. That is the first classification based on which modulating signal we are using. Then modulation can be done by varying three parameters of light, that is intensity or frequency or phase or polarization of the light. So as in case of analog modulation, there are three types based on which parameter of carrier we are changing: amplitude modulation, frequency modulation and phase modulation. Similarly, for light modulation also, based on which characteristics of light we are changing, there are three types of the modulation: intensity modulation, phase modulation and frequency modulation. So out of these three, the intensity modulation it is most commonly preferred, in which we are changing intensity of light with respect to the modulating signal. So if we are using analog modulation, intensity of light will be changing with respect to voltage of the modulating signal at each point. That is the concept of intensity modulation by using the analog signal. Here the intensity will not be zero at any point, but if we are using the digital signal as a modulating signal, When the digital signal is having one value, we will get light at the output. When it is having the zero value, we will not get any emission of light at the output. That is the concept of the intensity modulation by using the digital signal. So LED can be directly modulated simply by variation of their drive currents at rates up to many gigahertz. This is the direct modulation method. So intensity modulation may be utilized with both digital and analog signal. Analog intensity modulation is usually easier to apply, but it requires comparatively large signal to noise ratios, and therefore it tends to be limited to relatively narrow bandwidth and short distance applications. So if you compare the analog modulation and digital modulation, in case of signal to noise ratio and linearity provided by the particular system, the digital modulation, it is more advantageous as compared with the analog modulation. So alternatively, digital intensity modulation gives improved noise immunity but requires the wider bandwidth. So if you compare these two, digital modulation, it is more preferred as compared with the analog modulation. So these are the main things related to the modulation of light. So in this session, to summarize, we have seen 5 characteristics of LEDs. First one it is, so before studying this characteristics, general characteristics we have considered that LED is a chromatic source of light. It is non-chromatic source of light. We are not getting intense beam of light at the output. Coupling losses are more in case of LED as compared with the laser. So we have covered 5 characteristics. First is output optical power, that is graph of output power versus the temperature. In this, as the temperature increases, the output power decreases exponentially because quantum efficiency of LED decreases exponentially. That is the first point. Second, output spectrum, that is graph of the output power versus the wavelength. If the output spectrum is narrow, that means the wavelength difference is less and we are getting chromatic source of light at the, or we are getting the intense beam of light at the output, means the source it is chromatic. If the output spectrum is wide, that shows more wavelength difference, and the output spectrum it is, or the chromatic source of light, it is not used at the input. That is the output spectrum. And what is the effect of increase in the temperature on output spectrum, that is also covered. So as the temperature increases, the output spectrum gets broadened. That is second characteristics. Modulation bandwidth. Firstly, we have seen the definition of modulation of light. Then with the help of this graph, we can prove that optical bandwidth it is larger as compared with the electrical bandwidth. Then reliability, we have seen reliability is considered by considering degradations. In case of laser, catastrophic and gradual, both the degradations are present. So reliability of laser is less. In case of LED, only gradual degradation is present. So reliability of LED it is more than laser. Then fifth characteristics we have considered modulation of light. So in modulation of light, light is acting as a carrier signal. There are two types basically, analog modulation and digital modulation, based on whether analog or digital signal is used as a modulating signal. Then based on which parameters of LED are, or which parameters of light are changed, intensity, frequency or phase, there are three types of modulations called as intensity modulation, frequency modulation and phase modulation. Out of these three, the intensity modulation it is used. So in the exam, based on this point, the question it is asked as explain the LED characteristics, or it is asked as compare the characteristics of laser and LED So based on these 5 points we have to write the explanation or comparison between the different characteristics of LED and laser. Okay, thank you.